Today we're gonna start right off the bat with a simple example, because I'm hoping to cram a second topic in today. We'll see how that works out. I'm gonna start with a simple class, and to keep the example from last time, I'm gonna call this class player. And a player will have health, and we're gonna split that up in two parts. Let's say int max health for how much health the player will have at most, and another integer for current health. Should probably shortcut this a bit, but whatever. Current health. And now whenever we change the player health by attacking them maybe, or by healing them, we can change current health, which can drop down to 0, let's say, or it can go up to max health at most, right? But let's say we're being clever, unnecessarily clever. In that case, we might decide to forgo the second variable and try to cram everything into a single variable health. That should contain both the maximum and current health. And we can do that using a trick that I've shown you a couple lessons ago when we talked about how to create custom data structures. The workaround to storing two integer values was to cram them into a single long, which has the same amount of bits. And maybe we'll make it a bit easier here. Let's assume the health of a player can never exceed 1000. Like, that's gonna be the maximum they're gonna have throughout the entire game. 1000 health would need 10 bits or less. So that means we have to reserve in this integer 10 bits for our current health and 10 bits for the maximum health, which is just 20 bits. Perfectly fine to store that in a 32-bit integer value, or well, 32-bit signed integer value. We actually only have, well, technically it depends on how we use the operators, but still way less than we have, so we're fine. Then let's write a simple method to get the health. This is mostly exercise because I want to show off some bit fiddling, because I think it's a really cool topic. I love working with bits, shifting them around and checking everything. There's some really, really cool, I'm not gonna say hacks, but tricks you can use in most languages to make very efficient code when working with bits directly. Like making use of certain features of the computer or certain weirdness in some of the ways the programming language or computer might operate with bits. I'm digressing, aren't I? Let's make one method get health. Because we have two values, I'm not gonna return them in one go, I'm gonna return them as out variables. Let's say one is, wait, first is gonna be the int max, and the other is gonna be, now let's just shortcut it to current, to core, like that, and write the method. This is actually very simple. So let's assume we have bits 32 to 31, not 30, 32 bits in total, 31 to 21, nothing. Then 20, wrong again, 20, the same problem here. Then 19 to 10, and 9 to 0. This is current. This is max. And this is not used at all. Let's put it like that. So 32 bits in total. The first 10 are the current health. The next 10 above that are the maximum health. I feel like it's lagging somehow. I think I have a bit low frame rate. I'm not sure why though. Well, whatever. And the rest of the bits we ignore. So to get the current amount of health, we just have to read the first 10 bits and ignore everything else. So that's health. Right, forgot. Fields. Lowercase. Like that. Health, and now we have to apply a mask, a bit mask, that will only allow the first 10 bits. To get a value that's only the first 10 bits, we can just go to a value that's a 1 followed by 10 bits and subtract 1. So 1 followed by 10 zeros, that's 1024. And if we subtract 1, that's a 1023, and that's 10 zeros, 10 ones. So all we need is to apply an AND, a bitwise AND with 1023. And for max, well, we take health, and we ignore the first 10 bits. We only care about the next part here, and we know the rest doesn't matter, it's gonna be 0 anyway. So we can just shift this over. Should make this a proper greater by 10. So after this operation, the bits that were at 19 to 10 will now be at 9 to 0. The rest is gonna be 0 anyway. So we can just store it in health and max, and we're done. So that's how we would be able to get the data. And let's set that as well. Let's say we have one void method set health. Let's specify max. And so we only want to set one part of health. Maybe we increase the maximum health. In that case, we want to keep the lower part that's already stored, but overwrite the one that's at the top. So we're setting health to health, or whatever, to the current health. And we only care about the lower part, that's what we're going to keep, the current value, which just is above here, 1023. And that is then gonna be combined with our maximum health. Okay, I'm gonna shortcut this a bit on the right here. Bit shifted over by 10. We're just gonna assume that this value is only 10 bits and not gonna mess with the rest of the data. I mean, in the worst case, the maximum health can be bigger than 10 bits, but we're not gonna worry about that now. And that would be the maximum health. Let's do the same again for min. Not for min, for current. Set health. That's a big U. Like that. Current. And this one is gonna set the health, but only in the lower part. We're gonna keep the upper one. And here's another neat trick we can do. So what we want is to use the old value health, but remove all the bits in the lowest 10 bits. The 10 least significant bits. So we want to set them all to 0. That means we have to create a number that's all ones except for the last 10 bits, which need to be all 0. So it's basically the inverse of this above here. The inverse of 1023, which is 22 zeros followed by 10 ones. We want now 22 ones followed by 10 zeros. So we could just use... Actually, we need some space here, because like that. And we could use this. How do you pronounce that in English? Is it tilde? This little wave character. 123. This is a bitwise negation that will just flip all the bits in that number. So this was all zeros followed by ones, and now it's going to be all ones followed by zeros. There's another way we can do this, however. Because it's a signed value, because it's just an integer, we can also go in the reverse. Because the negative value in the integer range is almost the inverse of the positive ones. Like we talked about 2's complement before. So negative value of 1023 would not be ones followed by zeros exactly, because we have to shift everything over by 1. 2's complement, this is not 1's complement, but instead of tilde 1023, we just use negative 1024. And basically it's always, when you make these masks, you can always just go for, we have 10 bits, so 2 to the power of 10, 1024, so it's either going to be 1023 if you just want the ones, or you're going to have the negative value 1024 if you just want these zeros. So it's actually pretty easy to figure these bit masks out. You can also write them out in hex value maybe, if you prefer that, but for cases like this, I find the decimal value a lot easier. If it's just 1 byte, it might actually be easier if you use the hex values, because they are more familiar, because there are a lot of bit masks that are just commonly used, and you know, your programming style, you do what you want. So this means health and the lower bits are removed. And then we can just add the current health on top. And we could now make an AND with another mask to make sure that current doesn't override everything. I'm just gonna say that current will not exceed the target value. So we're just gonna make an OR here. Save ourselves some trouble. Save the space. Again, technically not correct code. We're just making the assumption that these values are correct. We would need to verify that or apply masks to make sure that they are. But otherwise, this code would work. That was not intentional. Please go back to normal. And like that. So if I have a player P equals new player, we didn't define a constructor, so this player is going to start with a maximum health of 0 and current health of 0. I could now just say p.health equals 5. And this would be an issue. The intended way would be to use the method we defined, player.setHealth set health max, and maybe set this to 5, and then p dot set health current also to 5. So the player has 5 health in total, which is also the maximum. This would be the correct way. This way, we would now have the real value combined to this one integer, which is 5 times 1024. 5,120 plus, let's quickly calculate that. 24 times 5, 5,120 plus 5. So that's the value that we actually have stored in health after this. So we have 2 values actually, but they are visible as one single value. So the code I used, p.health, is a problem. This is correct code, it does its job, but it does the wrong thing. Because this just sets the current health effectively to 5, but the maximum health would be 0, which is kind of invalid. I mean, both the maximum health being just 0 is kind of weird, and the current health being higher than the maximum health is a bit weird. Incorrect state. How can we prevent this from happening? How can we prevent this code from being called? You could, of course, just make a little comment here. Don't write directly. And you could put this in as a summary, which we'll talk another time about, which would allow you to write some text that is always visible in most somewhat advanced IDEs when someone were to access this field health. But they could still do it. So if you work in a team and you create this class player and one of your teammates is now using this class player for their code, they might do the wrong thing without knowing. Or the teammate might actually be you in the future. You just write this class player and a couple of weeks later you just have to set the health for the player and directly access it through the field because you didn't really think about the more complex method you have to use. So ideally we have some way to prevent this code from being invalid. Someone let the computer flag us down as, hey, you cannot do this. And that is done, or at least one option for that, is done through a thing called access modifiers, which, as the name suggests, modifies the access you can have through keywords to fields, methods, or even classes, or structs, and a lot of other things. And there are a couple of different modifiers that exist that give different levels of access. Just how much do you want to deny people to access something directly? The one we're going to look at now is called private, which is not exactly the least accessible. If I'm thinking of something like file, technically that would be more. No, also not directly. Depends. If I make a partial class, then private extends to 2 files, and if I just use file, then it would be only 1 file. But in 1 file, I could still access it. Is there a private file list? I mean, we have private protected. There surely is. Okay, have to look that up later. That would be interesting, but let's go with more classical C# maybe for now. In that case, private would be the least accessible one. We do that by using the keyword private in front of whatever we declare, like this access modifier, the keyword is always the very first thing you write down, and then we would have the integer health. What we've done now is tell the computer that this field health is not meant to be used by anyone outside of our class. This code is completely valid. Computer would have no trouble here. Seriously, what's with the lag? Just give me a second, I have to check something with the Wi-Fi. I'm gonna be back in a second. And I'm back, and yes, it was the Wi-Fi. It was... I mean, the Wi-Fi worked, but it was the wrong Wi-Fi. I specifically chose a more local one to not have the lag, and this looks a lot better. You just can't see it. Let me check. OBS has to find the screen again. Please, react. That's the most annoying part about this. It's capturing the screen, but it's not really good at it. Like, once it found the screen, everything is fine, but it needs the initial trigger that something happened. There we go. Still haven't figured out what actually triggers it finding the screen. That's a bit weird. Anyway. Now without the lag, this part down here, still perfectly fine. But p.health, this would be an error. Can't be done anymore. The computer knows health is private. And what private means is that the only code that is allowed to directly use this field is code written inside this class. So only code written between these two curly brackets is allowed to use health directly. So these methods here, they're all part of this class. They're still part of the scope of this class. So they can just directly access health like before. It's fine. This code is outside of the scope of this class. So we're not allowed to use health anymore here. And that's actually already, there's to it already. By doing it this way, we can ensure that nobody will be able to directly inference health. Actually, it's not just setting the health, you would also not be able to see it. By the way, you also can't read it. But this way we can prevent anyone from directly accessing this variable and potentially doing something very wrong. They have to use these methods, which by themselves can also be made private. So I could make this method private. And this code down here would not work anymore, because this method is now private and only therefore accessible within this class. Of course, that's not the intention of this method. We want it to be visible outside. So we can actually specifically tell the computer, hey, we want this method to be visible outside. And that's another accessor, modifier, public, which is the most open modifier you can have. It's the exact opposite of private. Private limits you to only within the class, and public means everyone. This is basically what we've assumed so far our code to be. Which isn't the case, which wasn't the case always. But yeah, that's it for public and private accessors. It's that simple, really. There are more accessors, and they have some special meanings, but we're not ready to talk about those yet, because the use cases depend on other features we haven't talked about so far. Just remember, for now, private and public. And because this thing is private, something we do, this is just, again, naming convention, not something you have to do, but usually you would then use an underscore in front. Like this, lowercase and an underscore. This would indicate that, hey, this is a local field, not local, private field. So in here I also would have to add the underscore everywhere. I'm not gonna bother with rewriting everything. But this is how you would do that. Now, this method of accessing an internal field through methods is pretty common. As you can see, it allows us to store data in a way that's not obvious. Basically, we can restrict how the data is stored. We can set rules for how the data can be stored, and we can actually check beforehand if certain data is valid to be stored. There's a lot we can do by just running code on some values we want to store first to check, is it okay to store this data? Do we want to transform this data like we did here? So this way of hiding the actual field that stores the data from an external, let's call it user, but providing interfaces, providing methods for accessing this data indirectly is so common that in C# we have a special construct to make this process a bit easier, or to make it a bit more obvious which methods are just for accessing a field and which methods are for doing something specific, like the type of method we used so far. These are getters and setters, very special ones. In the easiest use case, we would have a single method, get health, would just immediately return the value for health, and another one, set health, for setting the health. Actually, let's do that now. Let's say we have another class. Let's say we have class chest. And this has a private modifier for an integer. Let's go gold. So a chest can have a certain amount of gold. And we might provide that in the constructor. So we have a chest which receives a certain amount of gold in the constructor, and then we set underscore gold, the local field, to our parameter gold. This doesn't look correct. Let me redo that. I swear, the moment I get these right is probably the moment the series ends. Right, like that. This way we can create a new chest and set how much gold is in there, and nobody will be able to change that afterwards, because nobody will be able to access this value because it's private. Which might be a problem, because when the player opens the chest, we need to know how much gold they get. So we make a method, get gold, which just returns the value of gold. This would be the very basic classic getter method, get method. And we can have, of course, the other way around. We can have a set method, which would allow us to change the amount of gold later. Maybe the player can store gold in a chest as well, for safety. And to make this a bit easier to distinguish from other methods, we have this idea in C# of properties. So what we do instead of this code up here, well, actually, let's keep this up here first. We also keep this constructor. Just let's move all of this a bit down. I'm not sure how much space I'm gonna need, so let's do a lot of space down here. And close it up here. Close it. Okay. Yeah, that's fine. Okay, that's better than nothing. So a property usually will be more visible, so we're not going to make it private. Actually, I'm going to write out the modifier this time specifically, public. Because we want other people to see this. And it's going to be an integer. It's going to look very similar to the method, the get method. The difference is we're going to call it the same way we called the field, just in uppercase and without the underscore. Just going to call it gold. And then we make curly brackets. So far, very similar to a method, but note that there are no normal brackets behind. We went from the name directly to the curly brackets. That's important. This is how you can distinguish, or easily distinguish, a method and a property. And now we have two new keywords you have to learn. One is get and the other is set. And they're used for properties. And only for properties. We don't care about the set, we only want the get. Because we now want the get part. And the get is just like a method that returns code. So this part looks like the method. We could define a set as well. This would be a bit different. There's another keyword you have to learn. So with the method, we had a set method. It would probably look similar to the constructor down here. Just not chest, it would then be void set gold. But it will receive some parameter like gold or a value or amount or whatever, and would just set that value into gold, underscore gold. Because we have a property, we don't really have as much of an I can't believe I forgot the name. I forgot the name. Signature. I was looking for a word with I, but no, it's signature. The I isn't the first letter. I'm sorry. So because it's a property, we don't have the same type of signature we would have with the setter method, with the argument. Doesn't really matter though, because the signature is pretty much predefined. We know it's an integer, and we know we are gonna set a value with another value, so there's only gonna be one parameter. The rest doesn't really matter. So there's a predefined keyword that is used in place of the argument you would add in a setter method in the signature, and that is called value. So value is a special keyword that you can use inside the setter part of a property that would let you use the value as it was the argument inside a setup method. But we don't want to set the amount of gold, we just want to read it, so we skip the entire setup part. And just leave it like this. We now have a property, gold, that is publicly visible, that lets us read the amount of gold that's stored privately. Okay, so if I now have a chest C equals new chest. Now we have a constructor with an argument, so let's say 100. 100 gold. And this would not work. Not health, gold. Doesn't work because it's private. But we can access... Oop, wrong page. Go back. C dot gold uppercase. And note again, no brackets here, so we also don't use any brackets here. This is not a method call. It acts like a method in a lot of ways, but it's its own thing. It's neither a field, nor a constructor, nor a method. It's a property. It has its own rules. You have to think of it mostly in terms of a method, but it has its very own rules. So we could say int g equals c dot gold, like that. With a getter method, would probably write something like get gold, like this. But we can save ourselves some writing, some characters, and just go directly to the property gold, not 6 old. That looks better. Like that. In the same way, if we had a setup part in this property, we could just write c.gold equals something, as if it was a field. So when you write this out, when you use it, it looks like a field, but when you define it in your class, it resembles a method more. Oh, by the way, you can also, of course, ignore the get part and only write the set part. So with a property, you can have a get and a set, or you can have only a get or only a set. You might be wondering, why would that make sense? Why would I want to have a set and not a get? Like, why should I be able to set a property but not be allowed to read it then? I mean, I'm setting the value. I know the value anyway. There are use cases, don't think about it. It is a weird construct. It doesn't happen often, but it can happen. Special circumstances. It's just, you should know that it exists. Now comes the question you should ask yourself. When should I use methods? When should I use properties? When should I just use a field? If it's about accessing internally stored field with no or almost no processing done on the values you store, use a property. There are cases where you have to do a lot of computing to set the value. Like you give some data and you want it to be stored, but internally the storage works very different from how you present the data. And then it might be better to use a method, because that communicates to a user of your class that this is very involved in terms of computing power and processing, which helps them making decisions on, do I write this now or later, or how often do I do that? Like, at least for me internally, that's always the deciding factor. Is there a lot of processing? Then make it its own separate method, so people are clear about this is doing some heavy stuff. But if it's just something simple as this, just a few operations, or maybe just setting the value directly, reading that, use a property. Of course, that's only necessary when you do any processing at all, or if you want to limit the access to a variable like this. If you don't need to change anything about the way the data is stored, and if people are going to be able to read and write the data freely as they want, then you can stay with the field directly. In most cases, it's pretty easy to upgrade from a field to a property later. Because if you imagine this being a field that's publicly visible, like maybe just go directly like this, well, you just rename this to underscore gold, make it private, and then add a property with the same name as the field before. And you're done. And then maybe, depending on what resources you have available, you change it to uppercase G, because properties you write uppercase, fields you write lowercase, and private fields you would write underscore lowercase. That's at least the naming convention that I use. It's not necessary. You can use whatever naming style you prefer, of course. One last thing about properties. All I'm doing here is returning the value for gold directly. And if I have the setter part, all I would do is, at least let's assume that's all I'm doing, directly sending the value, again this is the keyword value, into gold. No processing is done, nothing special is happening, it's pure exchange of data, we're just forwarding the data. For cases like this, we can also use standard getter and setter. Similar to how constructors, if they don't need to do anything, can be just left out and you have a default constructor that's doing nothing. You can also have default getter and default setter that don't do anything. So we just have get and we just make a semicolon. And that's done. And same we can also add a set. Semicolon. Done. The computer will automatically add the code that writes or reads the value. Here comes the interesting part though. Where am I telling the computer that I want to write this field, gold? I'm doing nothing here that indicates to the computer that I want this field. And sure, it's the only field right now, but what if I have two properties? One gold 1, the other gold 2. Or what if I have two fields on here? Which one is it going to choose? Neither. Actually, we can, if we write this out, maybe we just want the... Actually, let's keep the set in for now. If we have this property style here, we can completely drop this line. Because part of the default getter and setter definition is also adding a default field for gold. We would call this an auto property, because you define only the property that you need, and the computer automatically adds in the background a field, private field, that you access through this property. That changes also our code down here, because instead of underscore gold, which doesn't exist, which we have never defined it, we use the property. Uppercase gold. And now let's say we want gold to be only readable, but not writable. Well, then we change this to private set. We can still use the access modifier to limit how people are able to interact with this value for gold. Everybody can get it, can read it, but setting it is private. It's limited to the scope of this class. So it's perfectly fine to use it in our constructor. We're in the scope of the class, private is visible to us here. But outside, we wouldn't be able to do it. I can't set goal to something. I can read it just fine. Getting is public. But I wouldn't be able to write something in here. Because the default setter is private. Another thing to keep in mind, properties are basically a way to make getter and setter methods obsolete, to hide them away a bit, because getter and setter methods usually don't really do much, and having unnecessary methods in your code is just confusing, ugly. It's not so great. I mean, it's obvious what they do, but they still take up a lot of space, and if you look at the definition of your class or struct or whatever, having getter and setter methods just takes up space in your brain for figuring out what a certain class does. So properties are a nice way to get the benefits of having getter and setter methods, but simplified to something similar to fields. The important part is similar. In the end, under the hood, this is nothing more than a glorified getter and setter method. We still have internally a field, you can see it, the computer will define it for you. You have no access to that. Not with old language version. The newest versions do actually have another keyword that lets you access that property with that field, but let's not get into that. We're not starting with advanced C# yet. We're still pretty much in .NET Framework times with, let's say, 7.3. I think that was... yeah, Framework stopped at 7.3. So let's stop there for now as well. I lost my train of thought. Methods, yeah. So properties are basically methods to access a field. And there are situations where when you, for example, read a field directly, you can change it as well. Directly in... should probably just give you an example, but... okay. Let's make a small tangent here. We have a bit of time. I'm faster than intended. I probably forgot something again. Let's say we have a struct. Okay, let's just use simple names. Struct A has int I. Stupid simple. And then we have... I'm sorry. Let's say we have class B. Why am I writing so small now? Class B has an A. Ah, there we go. Class B stores an A. So we have a struct named A, which just stores an integer. And we have a class B, which internally stores 1A, one of those structs. So if I write code, let's see, B equals new B, like that. Now I can go b.a.i equals 1. This is perfectly valid. We have the dot operator that lets us access the field A from our B, this thing here, which is itself a struct, so we can use another dot operator to access the I field inside our field A, inside our variable B. This perfectly valid code. If we look at a simple table again, not so simple table. So we have our B, which we call B. And oh, yeah, let's make a simple drop here, because this is a class, so it's a reference, so actually we need to go down somewhere. Into the heap, so we have stack, heap. So in our stack we have our variable B that points somewhere in the heap where our B is stored. So that's why I'm skipping the name. And this B now stores in another table again, which has an A called A, which internally is another table with an I with a value of 0. Let's put it like that. Good enough. So B points to an object in the heap. B itself stores an A called A, which in of itself is directly a value storing an integer I. And if I access it now through b.a.i and setting that to 1, I'm directly changing this value here. So b.a.i, like this. If I read the value now and store that into an integer x, I'm reading this 1. So x would be 1. If, however, I change my a, so let's do it like we learned, public a. Okay, lowercase a doesn't make sense because it's a property, but let's keep it like that for now, just to keep the rest of the code equal. And let's say this is now an auto property with just the get part. Now I didn't put it on a new line, but you don't need to do that in C#. I usually do that in my examples here to give some more space for the code so you can see everything better. But you can also leave white space out. That's perfectly valid code still. So now we have a property, which is in itself basically a method that reads the value internally that's stored in A and then writes that back to you. It copies the value and gives that back to you. Return value from a method. What that means is, however, that when I call A, I'm not referring to this A in the heap directly anymore. I'm referring to a copy that is made temporarily for use in the stack for this operation down here. B.A gives me a copy of A, which I then can set to 1. Temporarily. Once this method is done, or once this assignment is done, our temporary value is gone and the heap still has only the 0. We get a copy, we change the value of the copy, and then we drop everything. Down here, we still refer to the original. Well, basically, we still make a copy, but the original still at the value of 1, so this is going to be 0 now. Does that make sense? Basically, by switching from a field to a method that gives us the value of the field, we caused an indirect access, which means we get a copy. If it's a field, we access the value down here in the heap directly. If it's a property, which is effectively the same as a get method, we get the copy of this value. So any changes are made in the copy we have temporarily in the stack, not the original value that's still in the heap. So that's where you have to pay attention with properties. They behave more like methods, so there can be unexpected circumstances. This also happens a lot with arrays. That's where it usually happens to me. So in this case I have explicitly class B, but I could also have an array of A's. That's the same problem then. Because basically array of A's is just another object that refers to a block of A's in memory in the heap. Same procedure though. Yeah, so that's properties. Looking at the clock, everything worked. I was a bit faster today because I wanted to show you something else, because I really want to finish this topic up so we can start next time with actual coding, so I don't have to write everything by hand anymore. No more curly brackets. At least not so often. Okay, so let's make a last class. And this class is gonna be, let's say, monster. Class monster has let's make it similar to the player. We have we're gonna ignore the access modifiers now. We're just gonna back to the old style with just fields. And max health. Just gonna HP now. Max HP and current HP, like that. And I can create now a monster. Monster A, which is a new monster. Like that. And another monster B. Default constructor. Like, the values don't make sense, but that's not the point here. What I've done now is created two different objects that are stored on the heap. So if we look at our table, in the stack, we have two monsters, A, B, and they have some address. We're just gonna skip the name. This is gonna be monster which is an, I'm just gonna shortcut this 0, 0, and another monster somewhere else on the heap. We don't know where. Could be directly behind it, could be completely different part of the heap. Star, which has another int 0, 0, and 1 points maybe here and the other down here. So that's the situation we have right now. Two entirely separate monsters, which point to entirely different objects. So whatever change I make to A, max HP 1, I could go to B and set current health or current HP. Let's be fancy, let's use -1. Very bad health. And that would affect these two references on the heap. So A was up here. A.max HP got changed to 1. Let's just use this. And current HP for B got set to -1. What if I wanted to set the value for the maximum HP a monster can have for both monsters at the same time? Or what if I wanted to set that globally for all monsters, not just these two? No matter how many monsters I have, each monster has its own value for the maximum HP. So every time I want to change the maximum HP all the monsters in my level can have for everywhere, I would have to go through each singular monster and every time call max HP equals something. Let's say the player sprung a trap and now all the monsters get a buff and every single monster has more maximum HP. A smart programmer might say, hey, I have all my monsters stored in some array somewhere anyway, so I can just iterate through them and repeat the same change there. But for our example, let's say we're not that smart. Or you could say we are smarter. Well, opinions. We're gonna make it so that all monsters share the same variable for the maximum HP. All the monsters everywhere, no matter how many we build, will have exactly one entry in memory that stores the maximum health. They all still have their own current health, but they all will have only one entry in memory that stores their maximum health, max HP. And that means we have to create a variable, a field for the monster that's not specific to a monster, but that's applied globally to monster as a concept. Every monster will have this one value. And to do that, there's another keyword, of course. And that is called static. Static tells the computer that whatever we put after this, it could be a field, could be a property, can be a method, technically it can be a class, but that has a special meaning. Whatever we apply to will apply globally. This is not part of a monster anymore. So basically this is gone. And I've removed more than I needed to. Like that. So we still have monster A and monster B. And they both still have the respective values in the heap, which stores the current health, current HP. But maximum HP is not limited to A. So I wouldn't call it a.maxHP. What I would use it as is monster.maxHP. I use the same name as the class to access this global value. The pattern is still the same as before. I use b.currentHP because I want to access the HP that's stored for variable b. So I go to b, current HP, set it to -1. If I want to change the maximum HP, however, that's not a value I can find in A or B. If I were to write A or B and try to look it up, like with current HP, there is no entry here. I cannot find any entry for maximum HP. I can, however, find that entry if I go to monster, the class itself. And to store these values, the computer will have its own separate storage area. That's not necessary for you to think about, just know that for each class, for each struct, whatever you have, if you write it as static, the computer will reserve some space to store exactly one of these. So by setting max HP here, every monster will now have a maximum HP of 1. Or I can set it to 10. And now all the monsters will have maximum HP of 10. I can still use internally in the class monster max HP like before. So for example, Let's move all of this down a bit. Like that. Let's say I want to write a method. And HP percentage. I want to see how much health does the monster still have in percent. What I do is just return the maximum HP, which I can use just like if it was not static. Maximum HP, then we multiply that by 100 because it's percentage, divided by core HP. HP, and be done with it. So even though this is a static, a globally applied value, I can still use it like before. I can also use the access modifier. I could call this private. So I can read the current HP of every monster from everywhere. But I could access the maximum HP only within this class monster. So externally I could not do this anymore. I could do this, however. But in our case, that isn't necessary. Let's just leave the private away and just use static. And what we have now is an instance method that's accessing a static value and combines it with an instance value. Instance would refer to these things. The actual objects, the values, the reserved spaces in memory for our monsters A and B. That is the instance data. Each of these memory spaces is one instance of a monster. And we have the static on the other end, which is only available in one singular space in the entire memory and exists as long as your program exists. From the very first time you access a monster until your program closes, this variable will be stored somewhere in memory. You don't know where exactly, but you can access it through monster.maxHP. That's all that counts. I can also write a static method. For example, let's say I want a static method that resets everyone's health to full. Let's assume for a moment I want to heal every monster to its full health potential again. Now, you might think I'm going to write static void. I'm going to put the static modifier again in front of the return type. This is how you write a static method. Let's just call it reset. Reset. And what I want to do is set current HP to max HP. There's a problem here. If I declare this as static, just as I did with the field on the top here, that means I'm not referring to a specific instance of the monster anymore. I'm referring to monsters in general, all monsters. Max HP is also a value that's available to all monsters. So sure, we can read the value from max HP. We can try to store that. But current HP, that's not available to all monsters at the same time. That's a value unique for each instance of monster. So this right here is not available inside the one singular static context of monster. The purely static part of monster, the one that's stored in one single memory location throughout the entire runtime of your program, does not have an integer current HP. It only has an integer max HP. So this is not possible. Current HP cannot be set inside a static method because it's not itself static. Static requires static. If you have a static method, everything inside that method needs to be static itself. So the computer knows where to look for the data, where to change it. If you want to reset all the monsters, then you absolutely do need some clever system where you have a pool of monsters, where you have an array of all the monsters that are currently on screen or in your level, and then iterate through all of them and reset. That's possible. But not this. If you want to reset, you can only do so with an instance method, without the static. An instance method can always access the one static context. That's true. That's possible. So we have always the static. That's one value. And we have the instance, which can have many, many different values. And they all can access this one value, 1 to m. But you can't go from up here down there, because you don't know where to. You can't access all of it at the same time. I mean, you might assume that the computer knows this stuff, but it doesn't. That's not how that works. You can only go one way, from instance to static, but never from static to instance. And last but not least, if I make a class static, which I can do by writing the modifier in front, static, that just means that this class is purely static. It doesn't have any instance part. Effectively, that just means the compiler will force you to write static in front of every single method and field you have, and properties. Which doesn't make sense for us. We want to have different monsters with different statistics, so we need to have different versions of monster. So we can't have it static. We have to have instance-based values, and that means the class needs to also be non-static. All right. A bit faster than probably good for learning, but we covered all the important topics now. Excuse me. Wait. No homework today. Just maybe review, because we've been a bit faster and I skipped over a couple of things. We will pick them up as we go in the future. I just wanted to get ready for next time when we write our first actual program and run it live in the stream. And that's the point where you will actually be able to write alongside and actually do homework that does something. Looking forward to that. With that said, I'll maybe do a review of every single topic we've done in our streams. The VODs are all online. You don't need to watch the VODs. Like, that's several hours of content, don't do that. Just maybe look through the titles and maybe try to figure out what we talked about in the past, all the different things that happened, just as a reminder of all the things you're gonna need next time. Let's say that's your homework. Just a review of all the topics we've covered. With it, we're done for today. See you next time.